We are going to start our class, guys. So chemical bonding and molecular structure, as usual, that we have seen yesterday also, right? Now, so there are so many structures that you can see here in our board, right? But right now you might be not able to find that what are these, right? So just only for your reflection part, that is linear, I have asked, right? And I have also asked that what will be the bond angle between this. So you can see here that the straight line is there. You might have heard something in mathematics that straight angle, and it is of 180 degree. Complex angle, straight angle, acute angle, obtuse angle, and there is what complementary angle, supplementary angle. So many angles are there in math, right? So one thing is there, that is straight angles. So that is what, that is of 180 degree. Yes, everyone, fine. If I am not wrong, so 180 degree, right? So you can see the diagram, that is linear, and now we have to see so many things. That is number of lone pair. Keep in mind that what are the things that we have to see: lone pair and bond pair, right? Bond pair. How many, like if any atom is bonded, so how many bonds are formed there, and how many lone pairs are there? So I think everyone is now aware of lone pair. Yes or no? Tell me, guys. If you are not knowing, then please tell me. I will be explaining that part as well. If I am asking lone pair, then what is the lone pair? Can anyone tell me? If let's suppose, see guys, see first here. Just a minute. O2 molecule is there, right? O2 molecule is there. O2 molecule is there. Can we find any lone pair there? Yes or no? See here, what happens? See, this oxygen is having a pair of electrons which are not bonded. Very good, very good. So see, the outermost electrons are how many? 6, right? The total number of electrons that are in the outermost valence shell will be what? 6. So you can see here that if these two, if these two electrons are there, then this oxygen will be having the octet completed. And how many? You can see here, this will be regarded as what? The electron that has been bonded, and after that what will be remained? That will be called as what? Lone pair. A pair of electrons which are not bonded, right? A pair of electrons which are remained after formation of bonding, right? That will be called as lone pair. Getting my point, Ivana? Am I clear here? No. So many structures are there. Trigonal planar is there. Tetrahedral is there. So we will be seeing these things in our upcoming lectures, right? So trigonal bipyramidal is there. Octahedral is there. So how many lone pair will be there? How many bond pair will be there? What will be their shape and what will be their geometry? That we'll be going to see in today's class, right? So this is for recall part. I hope this is well clear to you. We have drawn these things in our class. Yes, guys? No. So bonding. You can see a very beautiful picture. What do you say? I have told you in the last class also, there is a covalent bonding, and there covalent and coordinate bonding is also there, right? So what do you mean by SB will be telling me covalent coordinate bond. What is the meaning of this? Covalent coordinate bond. Or dative bond. If I will be asking you dative bond, what is this dative bond? This time SB will be telling me, because I know where so many students can tell me from this class. But SB you have missed your yesterday's class, that's why I'm asking you. What is this dative bond or covalent coordinate bond? Can you tell me that what is this coordinate covalent bond? Please turn on your mic first, I'm not able to hear you. You are not audible, your mic is not on. Yes, SB, can you tell me? Do you remember that what is this covalent coordinate bond?
Sir, can you hear me?
Yes, now I can hear you. Do you remember what is this covalent coordinate?
Sir.
Yes, what is this? Anyone from this class? Bhuwana, can you explain what is this coordinate covalent bond? Yesterday only I have explained this coordinate covalent bond. Can you tell me? Anyone? Anil Dev? Can you tell me what is this coordinate covalent bond? Yes? Okay, please explain then. Yes, yes, do fast because I am not having much time. We have to explain so many things today, right? Yes. Please go ahead.
Sir, can I?
Yes, 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 Anil Dev.
Sorry.
Yes,
So, native bond is also termed as a coordinate covalent bond.
very good.
It is a type of chemical bond in which one atom provides a shared pair of electrons
Mhm.
for the formation of a bond, and it is a one-sided sharing because the another atom does not share any bonds with
Very
its
good, very
to
good,
form
very
one
good,
bond.
very good. Guys, give a big hand for this for Anil Dev because he has really explained very well. Right. Yesterday only we have seen that if let's suppose if you and your husband is earning and if they are sharing, it means what? There is a covalent bond is there. But you, like let's suppose you are boy, so you are earning and your wife is not earning, right? But you are sharing, right? But you are sharing. It means what? There is what? One side sharing is there, right? So there can be a formation of what? That is also shared, right? So that will be a case for coordinate covalent bond, right? Yes or no, guys? And I have given you example also for the formation of hydronium ion, H plus ion, how they have formed. Yes or no, guys? Do you remember or not? No. Okay, no problem. Now, see, today we are going to see so many structures, right? So that is structures in bonding that we will be going to see in this VSEPR theory, right? So what are the structures? First of all, yes, yes, SB, yes, please go ahead. Want to speak anything, SB? Want to speak anything? No, then I'm going ahead, right? See, guys, first of all, we will be learning the postulates of this VSEPR theory. What are the postulates they have, right? Then we will be learning about the structures, right? First postulate is what? Right. The shape of the molecule depends upon the number of valence cell. Shape will be depend upon. I will be writing the shapes. What will be the shapes of that? Right. See here, the shape of the molecule depend upon the number of valence cell, valence cell electron pairs that is bonded or non-bonded. Bonded or non-bonded means what? So if not non-bonded, it means what? There will be a lone pair, right? If there will be a lone pair, then there can be a different shape as well, right? If there will be same, let's suppose same number of bond will be there, then their geometry will be same, but their shape can be different if the lone pair will be included in that. Getting my point, everyone? Now, around the central atom, right? So let's suppose if I'm writing AB2 type, AB2 type, it means A is what? A is central metal, and this B2 is what? That is bonded atom to the central metal or central atom. SB, can you please? Yes, can you please? Are you there?
Sir, I rejoined again, sir.
Okay.
Uh, yes, sir, you asked me a question and it got cut off, sir.
Yes, yes, yes. Please go ahead.
A covalent bond, in the sense, electrons are shared between two atoms,
Yes.
and a coordinate bond is
I'm not
where
asking. I'm not asking coordinate. I'm asking coordinate covalent bond.
coordinate covalent bond is where there are two atoms and one atom uh, is shared with the other, but the other does not share its atom to this
So,
other.
okay, okay, fine, 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 fine. Okay, okay. Come to the class, right? Now, see here. So first line is clear to everyone. Now, second, pair of electrons in valence shell repel one another since their electron clouds are negatively charged. So electrons are negative charged, so they will be repelling each other, right? So due to that, there can be a different shapes and geometry will be there, right? These pairs of electrons tend to occupy such position in space that minimize repulsion, and that thus maximize the distance between them, right? So we'll be seeing the structures, then it will be more clear to us, right? Now next is what? A valence shell is taken as a sphere with the electron pairs localizing on the spherical surface maximum distance from one another, right? So there are some postulates that we have to learn, guys, that we have to see here. A multiple bond is treated as if it is a single electron pair, and the 2 of 3 electron pair of multiple bond are treated as a single super pair, right? That we will be seeing. Let's suppose so type of bond is there, right? Let's suppose atom is one and six atoms are bonded to this. Just like, can you say me that is, let's suppose CH4 is there, right? CH4 is there. So it is what? In C there is H is surrounded by, carbon is surrounded by 4 hydrogen, right? But there can be also a chance that is F6. If F will be surrounded with any atom, so F is having how many electrons in their outermost valence shell? 7 electrons are there. Sorry, 6 electrons are. Sorry, 1 electrons are there in the outermost. Or how many electrons? See, F 1s2, 2s2, 2p, 5 is there. So 5 electron in valence shell, right? 2p5, 5 electrons in valence shell, right? So it can form how many bonds? 5 bonds, right? It can form 5 bonds. But let's suppose if 5 bonds are not bonded, 3 of them are bonded. 3 of them are bonded, and there is 2 electrons are remain. So that will be taken as a lone pair. That will be taken as a lone pair. Getting my point? So where two or more resonance structures can represent a molecule, that VSEPR model is applicable to in such any structure, right? Now, so we are having some structure that is HF, right? Geometry is linear. SCL. So these are the things. But I am going to make you write something. Please have your notebook in front of you and start writing this first. First of all, we'll be seeing a type of AB2 type, right? AB2 type, we'll be seeing the shape, their geometry as well, and their hybridization as well. AB2 type, first one is this. Then AB3 type. AB3 type, then we'll be seeing what? AB2 and E2 or E1. I will be seeing first E1. Right? Getting my point, everyone? So now you will be asking, sir, what is this AB2 type? What is this AB3 type? What is this AB2 E1 type? Yes. So can you please tell me that? Yes, guys, are you there, everyone? Hello. Yes. Actually, there was some problem in here, so I was disconnected. Right. Okay. So where were we? We were AB2 type, right? If there will be AB2 type, AB3 type, AB2 E1 type. So what are these? Can you please tell me that? What are these? Yes, yes. So what are these? AB2 type, AB2 E1 type, then AB2 E2 type. Yes. Now one more will be there. What is this type? That is what? AB4 type. Let's suppose AB4 type will be there. Then 6. AB5 can be also there, right? AB5 can be also there. And AB4, in AB4 we can also write AB4 and E. first of all I will be saying that AB2 type. AB2 type means what? What is the meaning of this AB2 type? Can anyone tell me? Guys, can anyone tell me what is this AB2 type? No one? Yes, hybrid structure. Anil, very good. Hybrid structure. See, here A is what? Central atom, right? A is what? Central atom. B is what? That is bond. Yes, very good. Very good. Bonded atom. And E is what? E is that lone pair. E is what? Lone pair. Everyone is now clear with this. What is A? What is B? What is E? Is there any problem? Anyone? Please say me if there is any problem. No one is having any problem? Okay, fine. Now, say me if let's suppose if I'm having a structure. If let's suppose if I'm having a structure SP, if I'm saying SP hybridized. So can you please tell me? Can you please apply your reverse engineering that what will be the type here? Will that be AB2 type? Will that be AB3 type? Will that be AB2E type? If I am saying if the hybridization is SP, please think over this for 1 minute and then give me the answer for this. If you will not think, then I will tell you. No one is saying. See guys, what is this hybridization? If I am saying hybridization, then what you have to keep in your mind that is number of atom attached plus number of lone pair have a note of this. This will help you a lot in finding the hybridization of any, in finding the hybridization as well the structure, shape, everything. Getting my point, everyone? Have you written, everyone? Have you written this? How to find the hybridization of any structures? Have you find? Can you find the hybridization of any structure by this method? That you have to find that how many atoms are attached and how many lone pairs are there. So if I am writing AB2, it means what? The number of atom attached is how many? If I am writing AB2 type, so number of atom that is attached will be what? Can anyone tell me if I am writing AB2 type? Guys, please say me. 2. Very good. Only Anil Dev is writing the answers. Atachaya, can you please tell me if I am writing AB2 type? AB2 type means what? The number of atom that is attached. That A is what? A is central atom. A is what? Central atom. And B if I am saying. So B can be either this or either this, right? So two atoms are attached with this A, right? So number of atom attached is 2, right? Everyone clear now? So now if let's suppose number of atom is 2, getting my point? If number of atom is 2 and if number of atom is 3 and 4, then what will be the hybrid structure? See, if the number of atom attached is 2, so we'll be writing SP. Getting my point? SP. If number of atom attached is 3, then it will be SP2. Can anyone tell me how many electrons that we can fill in S? Maximum number of electrons that can be filled in S is what? 2. And 1 orbital is there in S. And how many orbitals are there in P? P can be how many? Guys, I have taught you these things in the class. See here. If P I will be taking an S, I am writing here, you can draw also S, P, D and F, right? In S, one box will be drawn, right? There will be 1. In case of P, there will be 3. Very good. In case of D, put 10 electrons will be filled. So there will be a 5 orbitals will be there. 1, 2, 3, 4, 5, right? In case of yes, very good Atachaya. In case of F, there will be 7 orbitals. 14 electrons will be filled in this. So 3, 4, 5, 6, and 7. Got my point, everyone? Got my point, everyone? So let's suppose if I am saying the number of atom is 4. If the number of atom is 4, so what will be the hybridization then? Then what will be the hybridization then? Anyone can say me? sp3. Can we write sp3? If the number of bonded atoms is what 5, then what will be this? 5 is there. 1s, 3p, and 1d will be there. Can I write sp3d? Guys, what do you say? If 5 is there, can I write sp3d? If 6 will be there, 6 atoms are there. So what we can write for this? sp3d2, s, 1s, then 3p, 5d can be there, and 7f can be there. 7f can be there. So can we write sp3d? If there will be 7 atoms are attached, then can we write sp3d2? What I can write for this? Can anyone tell me? For 5 sp3d, for 6 sp3d2, for 7 sp3d3, can we write like this? Everyone, if I am saying 8, saying 8, then sp3 and d, how many d will be there? 4 will be, d will be 4. Very good answer. So got my point, everyone? So how many? S will be 1, P will be 3, D will be what? 10, D will be 5, right? D will be 5, and F will be what? 7. So this can be the hybrid structures, right? That we can write by this way, right? Now, let's suppose if I am taking one example. That is what in case of, let's suppose AB2 type. Let's suppose here there is also an example. Just a minute. Yes. See, in this case, AB2 type, right? AB2 type is there. So what you can say for this? For AB2 type, here there is what? H2O is there. H2O is there. So what will be the hybridization for this? Can anyone tell me? What will be the hybridization for this? Anyone? In AB2 type, what will be the hybridization? No one can tell me. No one will be telling me the hybridization for this. Can anyone tell me for this? Anyone? Guys, please tell me. No. Okay. One another example I am going to give you. NH3. What will be the hybridization in this? If you will be seeing the NH3, what will be the hybridization here? How many bond pairs are there? How many bonds are there? Can anyone say me? Nitrogen, see guys. So nitrogen will be bonded with hydrogen with 3, right? See, NH3 is there, right? Pranam, how you are saying 5? Can you please say me? How you can say 5? See, NH3 is there, and we are knowing that the value. Just a minute, see here. So there is what? How many electrons will be left? Nitrogen is having 5 electrons in their outermost, right? So H is having how many electrons in their outermost valence shell? 1 electrons, right? So they will be forming like this, NH bond will be formed, right? And 2 electrons will be remain. So can we write these 2 electrons as a lone pair? Can we write like this? Yes or no? Please say me. So how many lone pairs and how many bonds are there here? Guys, what is the basic formula for hybridization? Total number of lone pairs plus total number of bonded atoms. Can you please say me? No one is writing anything. Guys, what has happened to you? Please say me that. Who will tell me? Atachaya, please say me. Please turn on your mic and say me. How many lone pairs are there and how many bonded atoms are there? in NH3 case? In case
Two.
of NH3, how many bonded atoms are there and how many lone pair are there?
3 bonded atoms are there, sir.
Bonded atoms are there. So can we write 3 first? And how many lone pair are there?
Yeah,
One,
one
one lone pair is there.
one pair of lone.
So can we write is 4?
Yes, sir.
So it will be a type of what? It will be a type of AB3. Can we
A-
write AB3 type?
Yeah.
AB3 type? Yes or no? Please say me. One is what? A is what? A is what? That is central atom, right?
Central atom, sir. Yeah.
Yes. So what we can
Yeah.
write for this? It is a type of AB3 type or it is a type
Yeah.
of AB4? First tell
AB3,
me.
sir. Yes.
AB, if it is a type of AB3, if it is a type of AB3, AB3E type, right? Because there is lone pair is also
Lone
there.
pair also. Yes, sir.
So AB3E, right? So
Yes.
what will be the hybridization for this? Can you please tell me for this? What will be the hybridization for this AB3E type? See guys, you have to see what? If there is AB3E type, so total number, so you have to take what? Total number of bonded atom is 3, number of lone pair is 1, so it can be what? SP, S1, and there is and 3 more will be there. So can we write it as SP3? Yes or
Yes,
no? First tell me this.
Yes, sir.
What will be this? SP3 will be there or not?
Yes,
First tell me
sir.
this. SP3. How many of you are saying that SP3 will be the hybridization for this?
SP3, sir.
SP3. Are you really comfortable for this?
Yes, sir.
Confident? Confident? Guys, what do you say? Confident or not? You can see here. If AB type will be there, then the geometry will be what? Linear. If AB2 type will be there, then the geometry can be bent either or it can be linear also, right? Now here you can see here NS3. It is a type of what? Trigonal pyramidal. Trigonal pyramidal, right? It can be a type of what? Trigonal pyramidal. AB3 type. Getting my point, everyone? Trigonal pyramidal. Why trigonal pyramidal? See, actually it is having how many? See, bonds are what? How many? 3? 3 bonds are there, right?
Yes, sir.
Yes or no? Yes, very good, very good. Very good, Anirudh. Yes, Anirudh. So can you please say me what will be the hybridization for this? SP3 will be the correct answer or not? Say me that first. SP3 will be the correct answer or not? First say me this first. Otherwise, I will be taking one another example. Why? Why say me this first? One another example I am taking. I hope then it will be more clear to you. PCl5 there. PCl5 is there. Say me that how many lone pairs are there? How many bonded atoms are there? Can you please say me this? PCl5 is there. Phosphorus will be having how many lone pairs? And how many bonded atom will be there? Guys, bonded pair will be what? PCl5. PCl5. Bonded atom will be what? See guys. PCl5. Bonded atom will be what? 5. So bonded atom will be 5. Number of lone pair equals to what? 0. Number of lone pair equals to what? 0. So it is a type of what? AB5. If it is a type of AB5, if it is a type of AB5, then what will be the hybridization for this? Can you please tell me what will be the hybridization for this? If there will be a AB5 type will be there, then what will be the hybridization for this? sp3d. Why as 3p will be there and y will be there, right? So who has written this? Atachaya. Very good answer. Only Atachaya and Anil Dev in this today's class they are writing. And then the why sp2 hybridization? And why sp2 hybridization? For previous, I forgot that. Okay. So sp3d, guys, if you are not able to first, if you are not able to right. So for S, 1 will be there, 1 bond will be for S, 3 will be for P, 3 will be for P, right? So 4 bond has been completed, right? Written, and 1 more will be D. I hope Atachaya has applied his this way only, right? Atachaya, same way you applied your brain. Got my point? So got my point, everyone. So now, if I will be going to ask you another question, will you be able to give the answer for that or not? Will you say that? Will you be able to give me or not? See, one thing more that you have to see that is what if AB will be type, if AB type will be there, then linear will be the structure, linear will be the geometry. If AB2 will be, if AB2 type will be there, then bent, or it can be what linear can be the geometry. Here, if AB3 type will be there, so trigonal pyramidal can be there, or trigonal planar can be there, right? Trigonal planar can be there. Or if AB4 type will be there, then tetrahedral. If there will be AB4 type will be there, then tetrahedral will be the geometry. Getting my point, everyone? Is it clear for you, each and everyone? Now you can see here number of electron pair around the central atom is what? 2. So it is what? AB2 type. Can we say AB2 type? So it is what? Linear, 180 degree. BeF2, BeCl2, BeS2, ZnCl2 are the examples for this. If the number of electron pair around the central atom is 3, so then it is what? BF3. So it is what? What you can say? What will be the hybridization for this BF3? What will be the hybridization for this? Can anyone say me? What will be the hybridization for this BF3? Who is writing the answer for this? See guys, BF3 is there. Yes, Pranav 3. So what will be the hybridization for this? Hybridization will be what? SP2. Very good answer, Pranav. Very good. Very good. Very good. SP2. That's a very good answer. If I am writing as CH4, right? I am giving you one more example, and in different way I am making you explaining this, right? C is there, hydrogen is there, right? So hydrogen is having how many bonds here? Carbon is having how many bonds here? 4 bonds. 4 bond, right? So if 4 bond is there, 1 for S, can we consider 1 for S? And 3, these 3 will be what? P. So can we write sp3? Yes or no? So it is a type of what? AB4 type. It is a type of AB4 type. Let's suppose if there could be a chance of AB3 and E. Sometimes it is written as AB3L, AB2L, AB2L, AB3L, or AB2E, AB3L, or AB3E. Getting my point? Are you understanding my point? What exactly I am going to say you? Either it is a AB2 type or either it is a AB3E type. E means what? That there will be a lone pair will be there, right? AB3. B3 means what? There will be 3 bond will be there and 1 lone pair will be there, right? So B3 is there. So how many? See how many orbitals will be used here? 1 for S, B3, right? So sp3. Getting my point? And 1 for D. So total number of bonded and electron pairs will be what? 5. If there is 5, so 1 S, 3p, and 1d. Getting my point, everyone? Is it fine for you, everyone? Getting my point or not? If there will be all together by adding your lone pair, your bond pair. So if you are getting 5 numbers, then it is a type of what? sp3d. If you are getting 4, then what is that? Then what will be the hybridization for that? If there will be 4, then sp3. If that will be 2, then if there will be 2, then sp only. If there will be 2, then what will be there? sp. Getting my point, everyone? If there are all together, if there is 6 or 7 will be there, then what will be the hybridization for that? Please write the answer in your comment box. I just wanted to know the answer. If there will be total number of bond pair and lone pair will be 7, so what will be the hybridization for that particular structure? sp3d3. So many answers are coming. sp3d3, sp3d3, sp3d3. Okay, guys. So I hope now you are very much comfortable with this. So the whole class will run around this only. Now you have understood this, how to find the hybridization. What is this AB2 type? What is this AB2E type? What is this AB3L type? What is this AB4L2 type? Now everyone has got this, right? If there any problem to anyone, then please feel free to ask me. I will explain once again, and then we will be proceeding towards our class. Vana will be telling me, Vana, if I am having AB4 type, then what will be the hybridization for this? Guys, I don't want to lose this question, right? Because I hope this type of question will be coming in your examination, and that time you are not able to find your hybridization. Hybridization is one of the important topic of your chemical bonding. This is coming. Hybridization, geometry, and their shapes. Three things are very much important in chemical bonding that you have to know. That is what one is geometry, another is hybridization, and third is shape. Shape can be different, shape can be different, right? I have asked from whom? Please first tell me. AB4 type will be there, then you have to answer whom I have asked. Whom I have asked, first tell me that. Vana. So very good answer is coming from Vana, right? So now everything is clear. Now one more question I will be asking from someone, then I will be proceeding there. Right. D. Arti will be telling me. Arti, you have to speak. First turn on your mic.
Sir.
Yes. If there is a type of AB2E is there, right? AB2E is there. So what will be their hybridization then?
SP3, sir.
SP3, are you comfortable? Are you really comfortable? Others, what do you say? Is he right or wrong? Pranav is saying SP2 and you are saying SP3. How this is right? See, you have to see here. B2E is there, right? A is what? A is central atom, right? A is what? A is central atom, right? So you don't have to care for this, right? You have to care for this only, right? B2 and E is there, right? So 2 for B and 1 for this. So total is what? 3. Total is 3, then you have to write what? SP2. Getting my point, everyone?
Yes, sir.
Arti, is it comfortable now?
Yes, sir.
Any problem?
No, sir.
No? Okay. Now, you can turn off your mic. Guys, now we'll be just speeding our class. I hope everybody is now understanding this thing. So I cannot wait much now, right? Now, see here. So if there will be what? If there will be CH4 type, so their bond angle will be what? 109.5 degree, right? And their molecular geometry will be what? Tetrahedral. One thing is clear here, that if there will be what? If BE is there, right? BE is there, and F2 is there. Let's suppose I can join this like this, right? So there can be a geometry will be that what? AB2 type. If AB2 type is there, then it is a linear, yes or no? If AB3 type is there, then it can be what? Trigonal planar. Getting my point, everyone? Trigonal planar. See guys, the shape can be different, right? Shape can be different, but geometry can be same, right? If let's suppose if there be AB2 type, the geometry will be always same, but their shape can be different. Shape can be either linear or it can be bent, right? How many of you are getting this? Shape can be different, but geometry will be same. Geometry is what? Either it will be a linear, either it will be a trigonal planar, either it can be a trigonal bipyramidal, it can be trigonal pyramidal, it can be what? Square, it can be square pyramidal, it can be square bipyramidal, it can be square planar, it can be square pyramidal, it can be square bipyramidal. So these are what? These are geometry, but shape will be different. What is that shape? Shape can be what? Let's suppose if I am saying bend shape, if I am saying seesaw shape, if I am saying what? So different types of shapes are also there in this chemical bonding. Getting my point? One thing is what? Geometry, you have to take care of that. One thing is what? Hybridization, that you have to take care of that. And one thing is what? That is shape, that you have to take care of all these things. Getting my point, everyone? Any problem till here? Problems, sir. There are so many problems are there. So this is a very new topic, and I'm not much comfortable with this topic. See guys, chemical bonding is there, and wherever there will be hybridization will be coming, wherever there will be bonding will be coming, wherever there will be a shape, molecular structure will be coming, there will be some difficulty will be there. But you have to learn so many things. As you know, you are having a good brain. You are in one time you are doing multitasking. So many chapters you are learning of maths, physics, chemistry, English, IT, so many things you are learning at one time, right? Okay, now see here. So that we have to take care of these things, right? No. So next is what? Let's suppose number of electron pair around central atom is what? 5, right? So 5 will be there. So their geometry will be what? So their geometry will be trigonal bipyramidal. Trigonal bipyramidal will be there, right? So the examples can be what? PF5, SbCl5. So these can be the examples for this, right? If the number of, it is a type of what? AB6 type. If it is a type of AB6 type, yes guys, very good. So if it is a type of AB6 type, then their molecular geometry will be what? Octahedral. If it is a type of AB type, AB5 type, then it is a trigonal pyramidal. Trigonal bipyramidal. Getting my point? Bipyramidal, why I am saying? That is one bond is upward and one bond is downward. Getting my point? Right, everyone? If there are total number of bond, that is 7, so what will be there? Pentagonal bipyramidal. Example will be what? IF7. Now, so these things we have seen. Shape of BeF2 molecule, that is what? Linear. We have seen shape will be different, but geometry will be same. So you may ask me one thing, sir, shape or geometry is different thing? Yes. Shape and geometry are different things. Getting my point, everyone? Geometry is what? That is bipyramidal, trigonal, square planar. This is what? Geometry. But shape is what? That can be different, right? Everyone? Now see here. So if BeF2 is there, so it is a type of what? AB2 type? Yes or no, guys? Please tell me. If AB2 type will be there, so their bond angle will be what? 180 degrees. Getting my point? Two bond pair are there. So it is a type of AB2 type. If AB2 type is there, so it can be linear. Yes or no? It can be what? Linear. So you can see here, shape of BeF2 is linear. Now, if BeCl2, ZnCl2, HgCl2 will be there, so it means if there will be two bond pair will be there, so it will be what? If there will be two bond will be there, it can, with central atom, so it will be a type of linear. The shape will be what? Linear. It can be a shape of linear, and the geometry can be what? AB2, or you can say linear. That geometry is linear, right? Getting my point, everyone? Now, see here. If let's suppose shape of BF3 molecule is what? Trigonal planar. So how their shape is there? That you can see here. How we have drawn this trigonal planar, that you can see. And it is a type of what? AB3 type. It is a type of what? AB3 type. And if AB3 type is there, so in exam, how the examiner will be asking the question? If the hybridization is sp2, so what will be the geometry of that molecule? If the hybridization is what? If hybridization is what? sp2, then what can be the geometry of the molecule? sp2 is there. So what can be the geometry? Please say me. sp2 is there. See, if AB3 type is there, sp2 I have said you. sp2 is there, and it means what? There can be three bond. If there can be three bond, so it will be a what? Trigonal planar. Yes or no, guys? Yes or no? So is it clear to you, everyone? Any problem? Is there any problem? Very good, SP2. Very written, trigonal planar. Very good, Anil Dev. Okay, now. So now you have seen here, trigonal planar can be where if there will be a type of SP2 hybridization will be there. So there can be a chance of trigonal planar will be there, right? But what will be the shape for this CH4 molecule? See, first here their hybridization is what? Reverse engineering. Their hybridization is what? SP3. If SP3 is the hybridization, then their shape can be what? It means what? That is bonded with four that is bonded with 4 atoms. If it is bonded with 4 atoms, then their shape can be what? What can be their shape? Tetrahedral? Yes or no, guys? Their shape can be what? Tetrahedral. That you can see here. Their shape is what? Tetrahedral. Fine, everyone. It is clear to you? Any problem? So we have seen linear. We have seen yes, Pranav. Yes. Do you want to speak anything?
Sir, SP3 means there can be a possibility for AB3E.
Yes, there can be a possibility of AB3 also, but their shape will be changed, but their molecular geometry will be not changed. Their
Okay.
shape can be changed because lone pair can adjust either upward, downward, anywhere. So their shape can be changed, but their geometry will be not changed.
Okay, sir.
Getting my point?
Yes.
Okay, fine. So that you can see here, what is that tetrahedral structure, and their bond angle is what? 109 degree, 28 minutes, right? 109 degree, 28 minutes. And 28 minutes can be also written as 5 degree, but we are learning in this manner 109 degree, 28 minutes. Now PCl5. PCl5, this is a very famous structure and very much coming in here. This is coming in your examination. First of all, tell me if their PCl5 is there, so what will be the geometry and what will be the hybridization for this? How many of you can write the hybridization for this PCl5? What will be the hybridization for this PCl5? What will be the hybridization for this PCl5, guys? What do you say? What will be the hybridization for this? SP3D? SP3D, very good answer. It's trigonal bipyramidal, right? Trigonal bipyramidal that you are going to get here. The answer is what? Trigonal bipyramidal is the right answer for this question, right? Fine, everyone. Is it clear to you? Any problem till here? No problem. So PCl5. So their geometry will be what? Trigonal bipyramidal. Their hybridization will be what? SP3D. Very good. Now come to the next point. See here, PCl5 that we have seen, right? One more thing that I wanted to tell you what. That is, one is what? Axial, another is what? Equatorial. What is the meaning of this? What is the meaning of this? Axial and equatorial. Can anyone say me? Axial means what? This is axial, right? This is axial. And this will be called as what? Equatorial. Getting my point? This will be called as equatorial and this will be called as axial. Getting my point? Okay. Now, if there will be S of 6 molecule will be there. So how many? See guys. So if there will be what? It is a type of what? AB6 type. It is a type of what? AB6 type. If AB6 type will be there, then the geometry will be what? Octahedral. And what will be the hybridization here? Who will be telling me what will be the hybridization here? SP3D2. Very good answer. DRT SP3D2, SP3D2. The answer is coming SP3D2. Very good answer. Everybody is understanding how to find the hybridization now. Everyone is clear, guys. But geometry you have to learn. Getting my point. You have to learn the geometry. Although you are very much comfortable in finding the hybridization, but geometry you have to learn, and you have to see. Although geometry is also easy. Why geometry is easy? You have to see the number of bond pair first and lone pair. Let's suppose if one bond pair is there and one lone pair is there. Just a minute, for the sake of understanding part only. One bond pair is there, one lone pair is there. So total number of bond and lone pair is what? 2. So the geometry will be what? Linear. Shape can be different, but geometry will be what? That is what? Linear. If there will be 3 bond will be there. Either it is a one lone pair is there, or either there is two bond will be there and one lone pair will be there. So their geometry will be what? Trigonal. Trigonal will be the geometry of that particular element, particular compound, right? But their shape can be different. For shape purposes, you have to understand exactly what is the total number of lone pair and what is the total number of bond pair, and you have to learn their shape. Getting my point, everyone? If let's suppose AB4 type is there, if AB4 type is there, it means what? Its geometry will be what? Tetrahedral or not? First tell me that. Geometry will be what? Tetrahedral or not? Getting my point, everyone? If there will be AB4 type will be there, so their hybridization is what? sp3, and their geometry is what? Geometry will be what? Geometry is tetrahedral. Everyone is clear? Till here, is there any doubt? No doubt. Then have a break of 5 to 7 minutes. Then we will be back. Then we will be seeing the next topic, right? Are you there, everyone? Please turn on the camera. Now come to the point. So we have seen this, right? Now, one more structure is there. That is IF7, right? IF7 is there. So what will be the hybridization for this IF7? First of all, tell me this. Everybody has given the hybridization for this. Hybridization for this IF7, guys. What will be the hybridization for this? Please turn on the camera, guys. Everyone, please turn on your camera. Atachaya, SB, Anildev, Ashwin, Karthik, please write the hybridization for this IF7. What will be the hybridization for this IF7? IF7. What will be the hybridization for this I? sp3d3. Okay, you have given the answer earlier, right? Okay. sp3d3. Yes, right answer. Right, everyone? Fine. Now, now one more thing that we are going to see is what? Now, this here, we can see here either it will be a AB3 type or AB2L type. What is the meaning of this AB2L type? It means what? There will be two bond and one lone pair will be there. There will be two bond and one lone pair will be there. So the hybridization, there will be no change in hybridization, right? Getting my point, everyone? If there will be two bond and one lone pair will be there, so will there be going to change in hybridization anything? What do you say? Hybridization will be same. That is what? That is what? sp2? Yes or no, guys? Please say me. Their geometry will be also same. Geometry will be also same, but their shape will be changed. Getting my point, everyone? Their shape will be changed. Geometry will be same. Hybridization will be same. Even there will be lone pair will be there and two bond pair will be there. Then also there will be change in what? Change only there will be a change in shape only, right? Getting my point, everyone? Is there any doubt? So see here. So you can see here BF3 is there, right? That we have seen in the case of BF3, that we have seen there also. Let's suppose if there will be any lone pair will be there. What has been said here? If it contains lone pair in addition to bond pair, the geometry gets distorted. For example, a molecule of type AB2L, where L represents lone pair and has V-shaped geometry as discussed for SO2 molecule, right? So the geometry will be what? Like their shape will be what? The shape will be V-shape, right? Or you can say bent shape. Now, fine. You can see here the shape for this SO2 molecule. You can see here what is there. There is lone pair is the one lone pair is there, and there is what? There is what? Bond between the oxygen. Getting my point, everyone? Getting my point? Is there any doubt? No. See here. If there will be a type of what? AB3L. AB3L. Can we say like this? AB3L. Or it can be what? AB4. It can be what? AB4. Or what we can write for this? AB2. L2. Because two bond will be there and two lone pair will be there. Yes or no, guys? What do you say? Is there any doubt for this? AB4 type. Either we can say AB2 type, AB2L2 type, or we can say AB4 type. Yes or no? AB2 or AB2L2 type, or AB4 type, or we can say what? AB3L type. It means what? There will be one lone pair and three bond will be there. And here it will be what? Two bond pair will be there and two lone pair will be there. Two bonded items and two lone pair will be there. Getting my point, everyone? See, here in the case of three bond pair and one lone pair, that is what? Three bond pair and one lone pair is what? That is NH3. That you can see here. And nitrogen is having how many bonds? You can see here 3 bonds will be attached with hydrogen and 1 lone pair will be there, as total number of electrons in the outer valence shell of this nitrogen is what? 5. Getting my point, everyone? 5, yes, very good answer. So 1 lone pair will be there, right? In case of 2 bond pair and 2 lone pair, that is in the case of hydrogen, and that is in the case of water. Getting my point, everyone? See how this water is an. Are you knowing how this water is having how many valence electrons are having in case of oxygen? 6. Yes or no? Please say me. Total number of electrons in the valence shell of oxygen is what? 6. And S2 is there, right? If S2 is there, one electron of hydrogen and 1 electron of oxygen will be shared. So if there is 2 hydrogen, so 2 electrons will be shared. So total number of electrons that will be remained with oxygen will be what? That is 4. If 4 electrons is there, it means what? How many lone pair is there? How many lone pair are there? Guys, how many lone pair will be there? If 4 electrons are remained with oxygen, so 2 lone pair will be there. Getting my point? So the best example is what? H2O. So see guys, I am drawing the structure for this hydrogen is what? Water is what? O, right? How many electrons are there in their outermost valence shell? That is 6. Right? One will be shared with the hydrogen and another one will be shared with the hydrogen. Right? So here you can see here 4 electrons will be remain, right? 4 electrons. These are what? This electron. This will be what? Electron. So this is what? This is nothing. This is lone pair. So 2 lone pair will be there for this H2O molecule and 2 bonded atoms are there. So although their hybridization will be same. Why? It is a type of AB4. If AB4 will be there, so it will be what? sp3 hybridized will be there. So hybridization for this oxygen in water is sp3. Getting my point, everyone? It is clear to everyone, each and everyone in this class? Is there any doubt? No. I have told you in case of bonded atom, I have told you about in case of bonded and lone pair atoms, right? Now see here. If there will be a case of AB3L type ammonia that we have seen here, just now we have seen. So the geometry will be what? Tetrahedral, because what? Total number of bonded atoms or lone pair atoms all together it is what? 4. If 4 will be there, so it will be what? Tetrahedral. Getting my point? And I have shown you the shape of this. No. See the structure of this ammonia, guys. What do you feel? See, shape can be different, right? Shape can be different. If lone pair is there, so their shape is what? That we can, the pyramidal is that we are writing, but shape can be different, right? Geometry will be same, but the shape will be different. Getting my point, everyone? Any problem, anyone? Okay. Now, come to this. AB2 type, L2 type, that is water. AB2, L2 type, that is water. What is the shape for this? Shape of H2O molecule is what? That you can see here. There is 2 lone pair is there and there is 2 bonded is there. 2 bond is there and 2 lone pair is there. Their geometry can be tetrahedral, right? Their geometry can be tetrahedral. But their shape can be different. So you can see there, geometry is distorted tetrahedral. Getting my point, everyone? No. Now, in this case, if there is AB5 type, or you can say AB4 type, AB4L, or AB2L3. AB2L3. Getting my point, everyone? AB4L, AB2L3, or AB5. So the hybridization will be what? What will be the hybridization here? Guys, please tell me what will be the hybridization here. Can anyone tell me the hybridization here? Please write the hybridization in the chat section. SP3D, very good answer is coming. Atashaya, Pranav and Anil Dev is giving the answer for this. So there can be what? Their shape can be different guys. Why shape can be different? Geometry will be also same, but shape can be different. Why? Lone pair, the arrangement of lone pair can be different. The arrangement of lone pair can be different and number of bonded atoms can be different, right? Let's suppose this is just a maths you can say. I am having 5 bond, right? I am having 5 bond, right? In 5 bond, if let's suppose if I am having 2 lone pair, so 2 lone pair can be either in upward and 1 downward, and bond can be like this, right? So their shape is changed, right? But the geometry what? That is same. Geometry will be same. Getting the point, everyone? That is what trigonal bipyramidal. Why bipyramidal? That is 1 will be upward and 1 will be downward. Getting my point? When central atom is surrounded by 5 electron pair, the geometry is trigonal bipyramidal. Getting my point? Everyone, are you clear with this? Is there anyone is having any problem in this? Anyone is having any problem? No one is having any problem. Now come to the point. So guys, so we have seen like this. If there will be a 2 bond pair and 3 lone pair will be there, then that will be also a, there can be that will be coming in AB2L3 type. No. You can say in the molecule containing 4 bond pair and 1 lone pair, that is AB4L type, right? That is what? SF4. Sulfur tetrafluoride. Sulfur tetrafluoride, you can see the structure for the sulfur tetrafluoride. 1 lone pair is there, and what? That is 3 bond pair will be there, right? Sorry, AB4L type, right? So 4 bond will be there and 1 lone pair will be there, right? So you can see here, if there 4 bond is there, 4 bond, SF4. It is also called as seesaw. Getting my point, everyone? Is this clear to each and everyone? Okay, fine. Now this is the summary of what you have learned in today's class. What we have learned in today's class, that we can see. If there will be what? Total number of electron pair is 3, lone pair is 1. If there will be a what? AB2L type, number of bonding atom is what? 2, and number of lone pair is what? 3. So there can be a shape either bent shape or it can be V shape, and their examples are what? That you can see. And you can make a you can make one another box here, and you can give the name that hybridization. Getting my point, everyone? Shape you have written. Geometry at all the geometry has been written here, that is trigonal planar, tetrahedral, that is tetrahedral, again you can see here, right? So you can write that, right? Yes, you can write that, but you can write one like you can make one another box, and you can write here what? One another column that you can write here what? You have to write the hybridization. So if there will be AB2L type, so there will be what? Bonding, number of bonded atom is what? 2, 1 lone pair will be there. So total number of electron pair is what? 3. So arrangement, or you can say the shape will be what? Shape will be what? Either it will be a bend shape or it will be a V shape. And their geometry will be what? Trigonal planar. Getting my point, everyone? Now, if there will be AB3L type, it means what? There will be 1 lone pair and there will be 3 bonded atoms will be there. So total number of electron pair is what? 4. So it will be a case of pyramidal, or this is a shape will be what? Pyramidal, or you can say geometry will be what? Tetrahedral. Now again AB2L2 type, it means what? Total number of bond pair, total number of electron pair will be what? 4. The total number of electron pair is 4. So again it will be a shape, it will be geometry will be what? Tetrahedral, and shape can be what? V shaped as well. or it can be different shaped as well. Getting my point, everyone? Now, here you can see AB4L type. It means what? Total number of electron pair is what? How many? That is 5. Total number of electron pair is what? 5. Getting my point, everyone? And their shape is what? Trigonal bipyramidal. Trigonal, that is what? Triangle, you can say trigonal and bipyramidal. One is upward and one is downward. And the shape is what? Seesaw shape. Hybridization you can mention. Let's suppose if there will be AB3L2 type, it means what? There will be 3 bond will be there and 2 lone pair will be there. 2 lone pair will be there, right? So if 2 lone pair will be there, so it will be what? Trigonal bipyramidal. Guys, you can see here, geometry is not changing. Are you compatible with this or not? First tell me. If number of lone pair are changing, so their geometry are not changing, but the shape will change. Shape will change, geometry is not changing. Getting my point, everyone? So here you can see what is shape. Shape is what? Seesaw, but here is shape. Here the shape is what? T-shape. Now, here again you can see here AB2L3 type. AB2L3 type. Again you can see here their geometry is what? Trigonal bipyramidal. So total number of electron pair is same, so that their geometry will be not changed, right? But there can be, actually here there will be some mistake there. The geometry can be, the geometry can be, their shape can be changed. Now, here in case of, let's suppose total number, what bonding atom is what? Total bonding pair is what? 5, and one lone pair is there. So total in all around it is what? Total number of electron pair is what? 6. If it is of 6 type, then what will be the geometry? That is square pyramidal. Square pyramidal. Getting my point, everyone? Square pyramidal. Now you can see here, if it is a type of AB4L2 type, it means what? There will be 2 lone pair will be there. So you can see here 2 lone pair is there, right? If there is a 2 lone pair, so I hope everybody is now comfortable with this shape, geometry, hybridization. Are you clear with this or not? So many examples we have done. Guys, you have to learn the shape, geometry and hybridization. I hope everyone is clear with the hybridization. Shape you have to learn. Geometry, you have to see that how many bonded electrons are there, so that in this way you can learn the geometry as well. You have to see the total number of bonded atoms and total number of lone pair. And if that is, if you will try to make a short note on this, you can make that as well. Getting my point, everyone? Is it clear to you or not? Please first tell me that. Was this easy or not? To find the hybridization is so easy. To find but geometry and shape that you have to learn. What will be the geometry that you have to learn? But there is also a trick to learn that. What is the trick is that you have to see the number of electron pair. If the number of electron pair is same, so the same geometry will be there, but their shape can be different. Getting my point, everyone? Fine. Okay, now come to the point. Now we are going to learn about a very beautiful topic. That is what? VBT. Very beautiful teacher. This is what? Very beautiful teacher. Valence Bond theory. Getting my point, everyone? So this is what? This is very beautiful teacher. Are you having any very beautiful teacher in your class? Yes? So, Guana, oh my God, what happened? What you are eating? Mosquito? Yes? Okay. So guys, we are going to see about the valence bond theory, right? Just a minute. Okay, students. So now come to the point hybridization. Sorry. First of all, we have to see what valence bond theory. What is this valence bond theory? Why we need a valence bond theory? Can you please say me the answer for this question? See, actually, the VSEPR theory and Lewis dot structure was not able to say much more thing about the you know uh, about the geometry and the number of electrons about the in any compound. So in that way, to replace that, there is a new theory has been, like their hybridization was not much clear, right? Their hybridization was not much clear. So now the new theory has been come, that is valence bond theory has been come. And see, every theory there is some limitations are there. When there is a limitations in valence bond theory is there, so new theory has been also developed then. That is known as MOT, molecular orbital theory. After this, you will be going to learn about the molecular orbital theory. Now you are going to learn about what? Valence bond theory. So, do you have any idea? Anybody is having any idea about the valence bond theory? Anyone is having any idea? No one is having any idea. Is it to explain the chemical bonding? See, actually we are learning the chapter chemical bonding, so obviously there will be something of chemical bonding, right? But basically this is for the hybridization purposes, right? Getting my point. One, how to excite the electron and how to make the hybridization, that we are going to learn in this topic. Getting my point, everyone? So now see here, valence bond theory. So actually what happened, the valence bond theory is based on the knowledge of atomic orbitals. Yes, you can say. So the valence bond theory is based on knowledge of atomic orbitals and electronic configuration of element, right? And overlap criteria of atomic orbitals and stability of molecules, right? Getting my point, everyone? Is it clear to you? Now, the basic assumptions. What are the basic assumptions of this valence bond theory that we are going to see is what? The atoms do not lose their identity even after the formation of the molecule. Atoms do not lose their identity even after the formation of the molecule, right? So let's suppose if O2 is forming a molecule, right? O is forming a molecule that it is combining with O2. So it will not try to lose its identity. Getting my point? Even if you will be having 1 crore rupee in your account, then also you will be, then also you will be going to bargain for one rupee coin. Yes or no? When you are going to a shop for for having notebook, for some time book, even if you are having 1 crore rupee in your account, this is an Indian mentality that I am saying, right? So what we are doing, oh, it's a 10 rupee, no, I will give you 8 rupees only. Getting my point? So this is what, that we are having this identity, that we are not losing that. Getting my point, everyone? So same happens with chemistry, right? Chemistry is what that I have taught in the very first lecture, that there will be so many things that are similar to their daily life, right? So now see here. So the first thing is that the bond is formed due to the interaction of only the valence electrons. As the two atoms come close to each other, the inner electrons do not participate in the bond formation. Getting my point, everyone? So how the bonds are formed? You can see here. Let's suppose if I'm seeing carbon, right? Carbon is forming bond with hydrogen, right? So although carbon is having how many electrons? 1s2, 2s2, and 2p2, right? 2p2 is there, or what is that? Boron and carbon. 2p2 is there. So these are what? These are inner and these are filled. You can see these are what? These are filled. So only this, see, actually in carbon what happens? Sorry. In carbon what happens? Actually this also participate in bond. This also participate in bond, right? S also participating. Actually there is excitation and this electron comes out. Although they are in pair, if I will take about the carbon, what happens? If I will talk about the carbon, see, 1s will be filled, right? 1s2, and again what? 2s2, right? 2s2 will be there. So s will be filled like this. Getting my point? And 2p2 will be there. 2p2 will be there, right? Everyone. So it will be filled like this. But what will happen? There will be excitation of this carbon, and one electron will be, from here, from S to P will be jumped, right? So now, how many electrons will be there? So you can see here, 3 of this, and now if you will be making the new diagram for this, it will be like this. And 3 will be from P. So now these electrons can, yes, describing the electronic, yes. So this electron will participate in bonding. Getting my point, everyone? This electron will be participating in bonding. Getting my point, everyone? Is this clear to you? Fine. Now see here. During the formation of bond, only the valence electrons from each bonded atom lose their identity. The other electrons remains unaffected. So you have seen how they will be unaffected. The stability of bond is accounted by the fact that the formation of bond is accompanied by release of energy. The stability of bond is accounted by the fact that the formation of bond is accompanied by release of energy. The molecule has minimum energy at a certain distance between the atoms, known as internuclear distance. Larger the decrease in energy, strong will be the bond formed. So what I want to say you is what? Once the bond will be formed, or what you can say, here the larger the decrease in energy, strong will be the bond formed. Once the bond will be formed, the energy will be decreased. Getting my point? Before bonding it will be having higher energy, but after the bond will be formed, their energy will be decreased. So what has been said here, larger the decrease in energy, stronger will be the bond form. Getting my point? No. See guys, there is a graph between bond energy and bond length, right? Do one thing, it's actually 9:30, 9:15 will be there. So first start your class assessment part. The rest of the things will be delivered in the next class, right? Start with your class assessment. Only 15 minutes is there. Do one thing, just a minute. Let's do this question. First we will be doing this question, then we will be moving towards the, for the class assessment part. Just see here. If I will be asking the hybridization for this carbon, how we can find the hybridization for this carbon? Guys, please open your eyes and try to solve the question. See here. What I'm saying is that CH3 and single bond C is there. CH3 single bond C is there, right? So what will be the hybridization for this? C. C is there, and there is what? How many H is there? So 3 hydrogen is there, right? So it will be arranged like this: hydrogen, 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 right? And 1 will be with this carbon, right? 1 will be this carbon. Getting my point, everyone? So what will be the hybridization for this carbon? What will be the hybridization for this carbon? It is a type, can we say it is a type of AB4? If it is a type of AB4, the hybridization will be what? sp3. Getting my point, everyone? Getting my point, everyone? So with all this, like for this carbon and this carbon, the hybridization will be same. Yes or no, guys? Only Anil Dev has replied. No one is answering. What do you mean? Vana, don't know the answer of this question. Atachaya, don't know the answer of this question. SB, don't know the answer for this question, or what? Why are you not giving the answer? Okay. Now, come to the next question. Here for this carbon. If I am talking for this carbon, see, this carbon is having CH2, right? CH2. So I am drawing the CH2 first. H and H. And there is double bond is there, right? If double bond is there, right? If double bond is there with this carbon, right? Actually, the structure is like this. Just a minute. Actually, there is something mistake, right? CS2 will be not there. Here there will be CS2 will be there only, right? It is not possible to write S3 here because double bond is already there. So it is not possible to write here as here will be 2. So guys, see here. So again, what will be there? C. If double bond is there, not even 2, it will be only CH. Because 3 bond is already there, right? So only H will be there. So see, if there is double bond is between this, so what will be the hybridization for this? Can you say, guys? If there is a double bond, or you can say if there is pi bond is there, if pi bond is there, so what we will be taking? What we will be taking? Only one bond I will be taking from here and 2 bond from here. So it is a type of AB3 type. So what will be the hybridization for this? For this carbon number 1. For carbon number 1, what will be the hybridization for this? What do you say, guys? AB3 type. So it will be sp2 or not? Very good answer is coming. Now come to the next point. Come to the next point. CS2 is there, right? So single bond is there, single bond is there. So here hydrogen will be there. So again, it is a type of AB4 type. If it is a type of AB4 type, then what will be there? Then it will be a sp3. Yes, sp3. Very good, very good. Now come to the next point here with this carbon. Carbon is attached with oxygen with double bond, right? And carbon is attached with hydrogen with single bond. And one single bond with this carbon is there, right? So what will be the hybridization for this? C2. What will be the hybridization for this? Guys, don't see the answer, only tell me how you have find the answer. Guys, for this double bond, I will be taking 1. And this for single bond, sigma bond, 2 bond will be there. So total number of bond is what? 3. If total number of bond is 3, then the answer will be what? sp2. Getting my point, everyone? For double bond, you have to consider 1 bond. For double bond, wherever there will be double bond will be there, you have to consider 1 bond. So the hybridization can be calculated very easily, right? Is there any doubt till now? Any doubt here? No? Okay, fine. Next question. If I will be going to asking for this carbon, So this is very easy question because this C, carbon, H and H is there and O will be attached with this carbon and this carbon is attached with this single bond. So the hybridization will be what? sp3. And this carbon will be also having the sp3 hybridization. So this is very easy question for you guys, right? No. One more topic from this only I am going to teach you, right? As it's 9:18 already. Just for sigma and pi bond I am going to teach you, right? This is a question and we will be finding the sigma and pi bond, right? So what is the sigma and pi bond? First see here, how to find the sigma and pi bond. See, let's suppose if carbon is there, right? So if I will be going to say you sigma and pi. Sigma bond means single bond. Sigma bond means what? Single bond. Wherever there will be a single bond is there, so it means sigma bond is there. Everyone is clear? Wherever there is double bond is there, there will be 1 sigma and 1 pi will be there. Getting my point, everyone? If there will be a double bond, so there will be a 1 pi bond and 2 sigma bond will be there. Yes? If there is a double bond, 1 pi and 2 sigma will be there. Bhuwana, I'm asking you.
Sir, it will be like 1 pi and 1 sigma, right? Sir, I can't hear you.
Hearing or not, that I have to see that. Yes.
Sir?
So 1 sigma and 1 pi will be there, right, everyone? Yes, don't beat him. Okay, Bhuwana, fine. So guys, so there will be 1 sigma and 1 pi will be there if in case of 1 double bond will be there. Getting everyone? Now, so now see here. So if I will be going to ask you that how many sigma and how many pi are there with this carbon. So what will be the right answer for this question? I just want your answer in only 30 seconds. What will be the number of sigma and pi with this carbon? Write your answer in the chat section, guys. What will be the number for this carbon? Like what will be the number of sigma and pi for this carbon? 4 sigma bond and pi what? Anil Dev, Atachaya, everyone, please try to give the answer for this question. Only one, no pi bond, sir, because no double bond is there. I am asking for this carbon. Carbon is having double bond. So I am asking what, how many sigma and how many pi will be there? How many sigma and how many pi will be there? No pi bond, sir. Why not pi? No pi. 1 sigma and 1 pi. Atachaya, 1 sigma and 1 pi. Very good. Anil Dev, very good. Others? Anyone can answer for this question? SB, Maurice, Mukeshwaran, Pranav, Guana. What is your answer, guys? I was answering for the question number 1, sir, the 4 sigma bond. No, I am not asking for the first. I am asking for this. 1 pi, 1 sigma, Guana, 1 sigma, Mukeshwaran, 1 pi, 1 sigma, 1 pi, guys. Okay. Those whom I have said very good, that is not good. The answer is totally wrong. Why? Please try to understand from here. See, guys. Here is what? C, double bond C. So it is very clear that here is 1 sigma, here is 1 sigma and 1 pi is there, right? 1 sigma and 1 pi is there. But you have forgot that the carbon is forming 4 bonds. Carbon is forming 4 bonds, right? So 2 has been formed here. So where will be these 2? Another 2 will be where? So you have to draw with hydrogen. There will be a 2 bond will be there. So then the structure will be completed. Even it has not been given in your question, then also you have to think over this, and then only you can give the answer for the question. So total number of sigma will be what? That will be 3, and 1 pi will be there. Getting my point, everyone? Yes or no? How to find the sigma and pi now? I hope everyone is clear with this. Yes or no? So I was knowing that you will be giving the right answer from your side, but the right answer is not that. What is the right answer then? How we can find the sigma and pi then? Is it clear to each and everyone? Is it clear? Is there any doubt, guys? No doubt. Guys, only in 2 cases there is no doubt. In which case there is no doubt? Can anyone say me? Either if you are knowing each and everything, there will be no doubt. And even in case if you are not knowing anything, then also there will be no any doubt, right? So justify yourself whether you are knowing or not knowing. Getting my point, everyone? Now, can you do this question? CH2Cl2 is there. CH2Cl2 is there. So can we find the number of sigma and pi? So this is a very easy question. So total number of sigma will be what? CH2 and Cl2 is there. So obviously this carbon will be attached with what? 2 hydrogen and 2 chlorine. So total number of sigma will be what? 4. Getting my point, everyone? Yes, everyone? Yes or no? Please say me. Now, do this question first. You have to find the sigma with this, no, that you will be able to find. Try to find the sigma and pi with this carbon.